Hello guys, in this video I'm gonna talk about linear systems of equations. First I'm gonna give you the definition of a linear equation. This type of equation is called a linear equation. Here the coefficients a1, a2, ap and b are real numbers. The variables x1, x2, xp are of powers 1. Let's look at an example. Suppose we have an equation 4x plus 12y minus 9z is 7. This is a linear equation because the variables x, y, z are of powers 1. That's it. Let's look at the definition of linear systems. A system of linear equations or linear system of equations is a collection of one or more linear equations. As you see here, the system is a collection of two linear equations. So it's a system of two equations. Let me generalize this example. A linear system of n equations with p variables is of this form. This one. Here, aij, where I changes from 1 to n, j changes from 1 to p, are the coefficients of linear system, which are given data. We know the values of aij. bi, where I change from 1 to n, represent the right-hand side of the system, this part, which are also given data. xj, where j changes from 1 to p, are the unknowns of the linear system to be determined. As I mentioned in lecture 1, our main goal in this topic is to define the solution of a system and solution set. A solution to the linear system of n equations with p variables is a list of ordered p real numbers that verify all equations of the system. The set of all possible solutions to the linear system is called the solution set of the system. And the solution set is denoted by this notation. Suppose that we have this linear system and the triples of minus 18, minus 6, 1. If we write minus 16, minus 6, 1 instead of x1, x2, x3 respectively, the equations will be true. Because of this triple is one of the solutions of the system. We have an important definition, and in order to solve linear systems we will use this definition. We say that two linear systems are equivalent if they have the same solution sets. In order to solve a linear system, we will transform it an equivalent and simpler linear system. Then we will find the solution set of the simpler linear system. That's it. Depending on solution sets, there are different types of linear systems. Let's look at this theorem. A linear system of equations has either no solution, one solution, or infinitely many solutions. According to the number of solutions, linear systems split into the following types. If a linear system has at least one solution, then it is called a compatible system. If a linear system has no solution, then it is called an incompatible or contradictory system. A determinate system is a linear system with a unique solution. That is, if a linear system has only one solution, then it's called a determinate system. And an indeterminate system is a linear system with more than one solution. Okay, if the right hand side of the system is 0, then it's called homogeneous. You know, if we take x1, x2, xp to be 0, this n-tuples will be the solution of homogeneous linear equation. Because of this, we can say that the homogeneous linear system is a compatible system. Look at here. Homogeneous linear system is compatible since it always admits the trivial solution x1, x2, xp are zeros. That's it. Okay, let me give you this example. First one, the system consists of n equations with n variables whose lines are defined as this one. Second system consists of 3 equations of 3 variables. Let's first solve the first one. S1 is this. Ith line is xi minus xi plus 1 is 1, where I changed from 1 to n, and nth line is xn is 1. Let me write this system more detailed. x1 minus x2 is 1, x2 minus x3 is 1, xn minus 1 minus xn is 1, and xn is 1. If we calculate the sum of all lines, it will be this. From 1 to n, Li is equal to x1 minus x2 plus x2 minus x3 plus xn minus 1 minus xn plus xn is equal to n. Here we can cancel x2, x3, xn minus 1 and in the end xn. From here x1 will be n. From here it follows that x2 is x1 minus 1 is n minus 1, and we continue this process line by line. Then the result will be this. x1 is n, x2 is x1 minus 1 is n minus 1, x3 is from here x2 minus 1 is equal to n minus 2, and xn minus 1 will be xn minus 2 minus 1. Look at here, x1 is n, x2 is n minus 1, x3 is n minus 2. By the induction, xn minus 1 will be n minus 2 is equal to 2. xn is 1. From here, as you see, for a fixed number n, this system has a unique solution. The solution set will be this. That's all. Let's look at the second one. Let me take S2 the system of x1 plus 2x2 plus 3x3 is 1, x1 plus x2 plus x3 is 2, x1 minus x2 plus x3 is 3, Okay, in order to solve this system, let's use the matrix inversion method. As you know, this system is equivalent to the matrix equation A times X is B, where A is the matrix of 1, 2, 3, 1, 1, 1, 1 minus 1, 1. X is a matrix of x1, x2, x3. B is the matrix of 1, 2, 3. To determine the matrix of X, we need to find the determinant of A and the adjoint matrix of A. I believe you know how to calculate the determinant and adjoint matrix. Because of this, I will write results directly. The determinant of A will be minus 4, which is different from 0. Because of this, the system of S2 will have a unique solution. The adjoint matrix of A will be the matrix of 2, 0, minus 2, minus 5, minus 2, 3, minus 1, 2, minus 1. As we know, the inverse of A is defined by this expression. 1 over the determinant of A times the transpose of adjoint matrix. Then in our case, the inverse of A will be 1 over 4 times the matrix of 2 minus 5 minus 1, 0 minus 2, 2, minus 2, 3 minus 1. From here we deduce that the matrix of X is the inverse of A times B will be minus 1 over 4 times the matrix of 2 minus 5 minus 1, 0 minus 2, 2, minus 2, 3 minus 1 times the matrix of 1, 2, 3, the matrix of B. If we calculate this part, it will be minus 1 over 4 times the matrix of minus 11, 2, 1 is equal to the matrix of 11 over 4 minus 1 over 2 and 1 over 4. Then the solution set of the system will be this one. 11 over 4 minus 1 over 2, 1 over 4. As you see, the set of solution consists of only one solution because the system has a unique solution. That's it. See you guys next lesson.